Hi, Professor. I wanted to go through the final question that's left on the random variables G6, and I'll go ahead and submit the updated, more cleaned up and concise notebook for you so that it's clear. The only questions that were left within this notebook was the final problem, and that was asking to find the expected x, to find the standard deviation, to find the variance, and then also to find the probability that x is going to be less than the expected x. So what I did is I went ahead and did this at the very bottom, separate from everything, so it's clear, it's away from any other notations. And so I'll go ahead and show you what I've done here to go through this. So going from top to bottom, I'll start at expect x. We found that expect x is equal to 5. What we did to find that was to use your PDF function that we have already. And what I did is I evaluated from a to b on an integral x PDF of x dx. And we find that our expected of x of going to be 4.9999, and I rounded that to call it 5. That was the expected value, the expect x, and that's how we found that equation using our live math software. From there, we're asked to also find the standard deviation. So from there, on the standard deviation side of things, what we need to do was to use our PDF function again, and what we did was a variance function. So x variance, I called it in this setting, from a to b. And what we did is that once we set that, it's from x minus expect x squared of the PDF of x dx. Once you go ahead and evaluate that interval, you're getting 0.359999 as your x variance. But what we know from variance is that standard deviation squared is going to be your variance. So in reverse that, your variance, the square root of your variance is going to equal to your standard deviation. So go ahead and take the square root of your variance, and that's going to be 0.599999. I call that 0.6. We'll round that up slightly. We're also asked to find the variance on this. So variance, again, we're using our PDF function. We're finding our expected value. And we're using an integral from a to b of x, PDF of x. Once we go ahead and evaluate that expected value of 4.999999, I called that 0.5. We know that our variance from there, we already have a lot of given information in this. We knew our variance is going to be equal to sigma squared, our standard deviation squared. So I went ahead and did that and got 0.36 as our variance, which is similar to the last one in reverse. They're kind of the same equations, back and forth. Variance and standard deviation have a lot in common. From there, we are asked to find the probability of x is going to be less than expect x. We know from our PDF equation and then our expected value function, we've already done this, but we need to figure out what's the probability of x going to be less than the expect x. So what we did is we use our expect x, or our mu formula. So we evaluate our interval not from a to b, but from a to mu, so that's going to give us our midpoint. So what's the probability that your random data is going to lie between a and the midpoint rather than over the entire encompassing value. Once we did that, we did from a to mu of PDF of x dx, we got our call it a cumulative probability. It's because we're going ahead and adding up all of our data points all the way up to the middle to find, or to that point that we're evaluating. In this point, we're evaluating the middle, and just as you would expect, that cumulative probability came out at 0.5. So we know that our probability of x being less than the expect x, or the mu, is going to be 0.5, which is just what you're looking for on a randomly distributed number set of random variables. Again, that was me going over the last piece of the G6 random variables notebook, going through all of the last questions in there to answer all of the concerns that you had. And I've gone over this in full and understand the material fully. Thank you, Professor. Appreciate it.